question, I believe it's 5 now that we're on. Yes. Okay, so we want to arrange the following in the order of increasing boiling point. So this person actually knows the correct order, but don't really understand why they're in this order. So let's just write it out. So arrange in order of boiling point. Okay, we have magnesium chloride, helium, okay, water, methyl chloride. Let me just think about that actually. Chloromethane is probably what that is. Yeah, that makes more sense to me. Argon and carbon dioxide. So that's a lot of them. So the way this one's going to break down is that we want to first separate it based on the type of I guess molecule or atom. So right off the bat, when dealing with atoms, helium and argon, the smaller it is, the lower the boiling point. So helium and atoms literally lose. If you're an atom by yourself, most cases 9 out of 10, you're gonna have a lower boiling point than everyone else. Okay, and they got that correct. So you're actually confused about the later part, but I'll show you how we can determine it. So we know it goes helium, argon. We have our first part. Okay, so that's how you take care of that. Now you want to do the next parts based on, if you remember, you know, your London dispersion forces and your covalent bonds and then your hydrogen bonds. That's what you want to focus on next. So, and ionic bonds, that's the last one before I forget. So with that, ionic bonds being the strongest, okay, an ionic bond, remember, is with a metal and a non-metal. Glancing over these, the only metal and non-metal is magnesium chloride. This right here is an ionic bond, meaning this is going to be the highest boiling point. So that one's going to be at the end, we add later. And that just helps us hone down to these three. Now, as I said, ionic is top, okay, so I'm going to write it actually down here. Ionic, which is the bond. Then it's going to be, well, dipole, dipole. But actually, you know, before I put dipole, because I know there's pretty strong dipoles, but hydrogen bond is like up there as well. Those ones beat out most, if not all, dipoles. Because dipoles, they still form, like, there's still a distribution of electrons just where they prefer to be, which does increase the boiling point, but hydrogen bond is like really polarized. And then after dipole, we have just covalent bonds, because it's not really much. It shows a difference. So dipole, you know, do technically count as covalent bonds, but covalent bonds, in this case, I'm implying that they don't really, the net charge doesn't really prefer to be anywhere, as in it's pretty neutral throughout, doesn't really have a polarity. And then that is pretty much how we break it down there. Okay, so with that, we're going to see in terms of these how we break down. So as I mentioned, hydrogen bond is the next one, so H2O follows suit, okay, because that's how it's broken down. So boiling points will increase this way. So we have the highest and the second highest. So now, as the student was asking here, how do you know between CO2 and CH3Cl? In this case, just draw it out and you will see from there. So CO2 looks like this. O, C, O. Okay. That one, as we mentioned, this will technically count as an SP, hybridization, because only bond two things, and it's linear. Okay, look at that, the pool is completely even. So this one will really be more of a covalent bond. It has no where it wants to be pulled to, hence how we get that. And when we draw CH3Cl, that one, Cl, Cl is quite high on the electronegativity scale. So this here will be kind of like G minus, attracting most of that charge in this corner. So everything will kind of be pulled this way towards the Cl. This is more of a dipole than this one. And because of that, because of literally that pull, that makes this have a higher boiling point than CO2. So if we were to finish this up, CO2 would actually be next, okay? Then CH3Cl, then H2O, then our ionic MgCl2, okay? And that's why, because CO2 doesn't have a pull, like it doesn't have any polarity. CH3Cl on the other hand does, okay? And here they do talk about it as well, actually. It's a non-polar molecule, so exactly, it's just a covalent bond. CH3Cl is a polar molecule, has that dipole, hence why it's stronger. And then H2O, as we discussed, that's a hydrogen bond specific case, that's why it's so strong. And then MgCl2 tops them all because it's an ionic compound. So exactly, this is correct. And now let's move to question 6.